everyone, welcome to this video. We're going to go through this logic puzzle. This is on Sporcle, it's by someone called Sporcle EXP. Put the link in the description. If we go down to this information, it tells us that adjacent, whenever it says that word, it includes diagonals. So A1 is adjacent to B1, B2 and A2. If you're going to play along, you have to put in 0 before single digits so that it registers. It tells us the prime numbers and chains. Not sure what that means, but when that comes up, that might become clear. We've got an answer thing in there, which might help us later, and we've also got this Excel document to help us as well. So we start off with 3 clues, which is a great start. We get 21. In C3 we've got 24. And down here we've got 16. And then we've got some clues to go along with that. So corners only contain composite numbers, so not prime in the corners. 1 2-digit non-prime number is adjacent to all of its factors, single digit factors, okay? 1 non-prime 2-digit non-prime adjacent to all single digit factors. So that means like 24, for instance, might be adjacent to all of its factors that are in the single digits. So 1, 2, 4, 8, all of them. But we don't know that it's 24. It could be 16. We just don't know which one we get. Then in C3 it tells us 1 row only contains prime. So 21's not prime, 16's not, and 24's not. So it's going to be either row 2 or row 4. Has only got prime numbers in. Each row has exactly 1 number greater than 20. And then each even number is diagonally adjacent to its half. Diagonally adjacent to half. Row 5 is in ascending order from left to right, so it's getting bigger. So 16, then something bigger than 16, etc., all the way up to this last one. Great, okay. Now we know that this number here, well, we got to have something bigger than 20. So these 5 numbers, 21, 22, 23, 24, 25, in 1 row each. So if we've got them in 1 row each, we'll have to have one of them in this bottom row. This E5 has to be the biggest number in there. So that means that this space has to be not prime, as we were told, but containing 22, 23, or 25. 23 is prime, all the primes here are underlined, so that only leaves 23 and 25 as options for that spot. Not sure yet which one it is, but they're the only 2 options that can go in there. And all of our numbers are going to go between 16 and 22 or 25. So this number needs to be bigger than 16, so it could be 17, or it could be 18, 19, we'll just write them. 19, but then we can't actually go any bigger than 19, because, oh no, we can have 20, actually. But then in this row, we can't go any bigger because we can only have 1 number that's in this bottom, the highest numbers. So we could have 17 there, then we could have maybe 18 or 19 or 20 there. And then we could have we've got to get bigger, 17, 18, then we've got 19 or 20. And then if we go backwards, we've got 20 or 22 or 25. 20 is the highest in here, so it can't be in that one. And then 19 is the highest in the previous one, so that can't be in there. So that leaves just a couple of options already for each of them. 17, 18, 19, 20 are the only options in these ones. Okay, so we can highlight those to show that they're all the options that are available for it. Evens are adjacent to halves, so if we write them down, we're going to have 1 is adjacent to 2, it's adjacent to 4, 8, 16, and that's it. Then 3 is adjacent to 6, which is adjacent to 12, which is adjacent to 24. 5 is adjacent to 10, which is adjacent to 20. 7 is adjacent to 14. 9 is adjacent to 18. And 11 is adjacent to 22. If we go up any higher, it'd be 13, but 13 doubled to 26, and that's not in our in there. So we want them to be diagonally adjacent. So this 16 here has to be diagonally adjacent to the 8. So that leaves just that as the only option in there. Straight away we know that 8 is there. And then the 8 has to be adjacent to a 4. Now we know a 4 can't go there, so it must go there. And again, the 2 has to be adjacent to that, so that's diagonally adjacent there. And the 1. They're the only options as it happens. So 1, 2, 4, 8, 16 are all done there. So it's nice and easy there. So we've got 1, 2, 4, 8, 16. Yep. Lovely, that was easy. And if we think about this being, for instance, an 18, we'd then have to have a 9 in this spot, this spot. Same if this was a 20, we'd have to have a 10 in here or here. That was 22, that would have to be 11. So, yeah. And then if we look at this, all one row is all prime. Well, these are not prime. These are not prime. These are not prime. And this 8 that we just put in is not prime, which leaves this one to be all primes that are in there. Primes again are the underlined ones here, 3, 5, 7, 11, 13, 17, 19 and 23. So they've all got to be in there. We know that this top corner is not prime, so we can get rid of that. 1 2-digit number is adjacent to all factors, to all single-digit factors. We could think about that. So if we list the 2-digit numbers that we've got that are not prime, because primes don't have factors other than themselves and 1, obviously. Well, actually, if we think about this before we do that, every number is going to have a single factor of 1. So we're talking about a number that's going to be in here. So these are prime, so they don't count. 2's prime as well. So these two spots have to contain a number that has a prime, that is not prime, that has a factor of 1 and could be 2 as well, and any of these primes. So yeah, we can do that for all of the primes, but sorry, all of the non-primes, but we don't have to think about the ones that are already done. And there's a few things we might be able to ignore as well. So if I put in all of them, they're the numbers that are left that could go in these two spots. Now, we also know that in these two spots, we can't have any number that's in this bottom row, 22, 23, 25. So we can get rid of those. They can't be in there. And we need it not to be a multiple of 4, because that's not going to be adjacent. So any that are a multiple of 4, like 12, can go, 20 can go. And then we've only got 4 options left, so we might as well list those factors. We've got 1 and 5 there. We've got 1, sorry, and 2. 1, 2, and 5. We've got 1, 2, and 7. We've got 1, 3, and 5. Or we've got 1, 2, 3, 6, and 9. Now, if there was any that had any of these numbers, they couldn't be. It couldn't be there. So if the number is here, we could have a 10, a 14, or an 18 because they've got this 2 as well. But we would need these prime numbers to be. So, for instance, if this was a 10, we'd have 1 and 2 already, but we'd have to have one of these two numbers be a 5, which would work because 5 is prime. If that was a 14, it's the same situation, but instead of a 5, we'd need a 7. And if it was a 15 in there, we could have a 3 and a 5, so that could work. 18, I think it's probably not going to work. We'd have to have a 1, which we have, a 2, a 3 would work, a 6 won't because there can't be a 6 adjacent, and a 9. Now, could we put this 18 in this spot? No, because it wouldn't be adjacent to a 2, so that can't be the number. So we're looking at just 10, 14, or 15 being in that spot. Could be here. Has to be there if it's 10 or 14. Could be here if it's 15. So we're not exactly sure which one it's going to be, but it's definitely going to be one of those 3. Right, and then here we need a prime. They're all prime. We also need a number above 20. The only prime that's above 20 is 23. So that means the 23 does have to be in this slot. It can't be elsewhere. And then in this one, we'd have to have either the 22 or the 25. Okay. So we need. Have we got any of these numbers so far? We've got the 24. 24's got to be diagonally adjacent to a 12. It can't be 12 here because it's not prime. So 12 goes there. Then 12's got to be diagonally adjacent to a 6. It must go there. Because these two can't be 6. And then that's got to be diagonally adjacent to a 3. So 3 must go there. Which is good news because that narrows down a little bit, I think, because the 3 is in that 15. So this could be a 10 or a 14, or this could be a 15. Not both, but one or the other. Okay, so that's those ones done. Do we have any other numbers on there that are not covered so far? No. Okay. Well, we got loads of things. We haven't put in anything yet. So we've got in this spot, we've got a 1. Then we've got a 2 there. A lot of these won't give us anything, but hopefully we'll get some information. We might not. There might be more to do before we get anything else, but we can see where we're at. And E3 is 6. Is that all of them? 10. 1, 2, 3, 4, 5, 6, 7, 9, 10. So, no more information, which means there must be more to work with here. So, let's think about if we put a 10 in this spot. We'd need that 10 to be adjacent to a 5 to satisfy that condition. We'd also need it to be adjacent to a 20 though, diagonally adjacent to a 20, which it can't be because these two are prime. So we can't have 10 be in that one. Let's think about the 14 then. So if the 14 was there, we'd have to have a 7, which would work in there. What about this 15? 15 and either a 5, but they're all there. So that seems to work. Okay. We've narrowed down though to either being a 14 or a 15. So that's quite good. I might just write the primes in that this could be. There is quite a lot, but at least then they're in. We can see if any can be ruled out then. So I believe it's the same in there and there. That's all the options for those spots. And remember we said a 23 can't go elsewhere, so 23 is done. It's got to go in that one. And in one of these 3 spots has to be 22 or 25. So we can put that in as well. It's not the only things that can go in though, so we don't want to highlight it in pink because it could be somewhere else, but we can highlight these ones because that's all the options for where they go. And that satisfies this each row, having something bigger. If we think about that 22, the 22 can only go in these 4 spots. The 22 can't be there actually, because it wouldn't be then diagonally adjacent to the 11, which is half of it. So that leaves only 25 to go in there. So 25 there. We can take off 25 in this one. We know that now the 22 must be in there. And if the 22 is in there, we need that to be diagonally adjacent to an 11, which must go in one of those 2 spots. We can take 11 out of the other spots. Can no longer be up there. So that's 25 that we put in place, then 11 is everywhere it can go. And the 22 is as well. So that's going to satisfy that. If we look at this 18, it'd have to be diagonally adjacent to a 9. So we can't have the 18 in there, which leaves only 19 there, which forces that to be a 20. Could an 18 be there? We'd have to have it well, let's say before we do that, let's do this 20. 20 would have to be adjacent to a 10, so a 10 has to go in there or in there. And then the 10 itself would have to be adjacent to a 5, diagonally adjacent, so that leaves only a 5 there or there. Cannot no longer be in this top one. Which, if it can't be in that top, can't be this 15 that satisfies it, so we've got to have 14. So 14's got to be adjacent to 1, 2 and 7. So the 2 and 1, the only place to cross there is that 14 there. So the 7 would have to be in one of those two. So again, 7 can go out of there. So we put 7 in all the spots it's got to go in. 5, 10. They're in all of their spots. So we're fast kind of running out of things that can go places, which is good. This 14 and 7 is going to happen from that. We've got 20, then 10, and 5. If an 18 was in here, we'd have to have a 9 in one of these two spots. So that seems to work, that could work, or we could have an 18. Where else could we have an 18? We could have an 18 and a 9, I think that'd work, like in these ones. So there's quite a lot of options for that. And then 11 and 22 we've put in all the spots they can go in. So we did put in some new ones there. We've got 1, 2, 3, 4, 5, 6 numbers that we haven't placed everywhere. So let's just put in those first. We'll see if we get anything. Yep. Single digit square numbers are adjacent to at least one consecutive. Single digit square adjacent to at least one consecutive. What else if we just put in? That's all of that. We've got a 19 in there, 20 in there, 25 in that bottom spot there. No more clues, but that helps us work with something. So single digit squares are 1, 4 and 9. So we've got a 1 which has got a 2 next to it, so that works. A 4, now a 3's already gone, which only leaves 5 to go in here. We've put all the 5's in all their spots. The only one that's adjacent is this 5, so that forces that to be a 5. If that's a 5, we need to have it diagonally adjacent to a 10, and then the 20 adjacent to that, so that works. We can get rid of the 5 out of there. 5 and 10 are done. So that's the 4 covered, and then the 9. So the 9 would have to be adjacent to either an 8 or a 10, which means the 9 could go in this spot or in this spot only to be adjacent to either a 9 or an 8 or a 10. So then we can look again at this 18. So if that was 9, that could be 18, that works. If this was 9, those two are prime, so that would leave this to be an 18, which again seems to work, but they're the only options again for the 18. So again, we've narrowed down a little bit. We've done those 5's. What have we got left for the 22? So 22 can't go there anymore because there wouldn't be an 11 next to it. And then the only place left for that 22 is here, which makes the diagonally adjacent 11. So again, 11 and 22 are done. A lot of these are in pairs, this game, which leaves the 9 just there as it is, which makes that an 18. Because all of these doubles, we just get, once we get one, we get the other quite easily. So that's all the diagonally adjacent except for this 7 and 14. We can kind of get rid of that because wherever it goes out of the 2 spots, that's done. We now have done that single squares. This 14 we know is that prime thing. We've got this spot, which we haven't done anything yet, but we know that that's got to be a non-prime. Now the only numbers we've wrote in the 7 everywhere it can go and the 23 everywhere it can go. And we haven't filled in these 2 spots. Well, the only non-prime that's left is the 15, so that must go there. And that means that this last spot is, we've just got these 4 numbers left that are written in here. Hold on, we've got 19 is gone as well. So there's 4 numbers left, 7, 13, 17 and 23. And they're the only ones that can go there. Obviously the 7 and the 23 are where they have to go, so that's why we've highlighted them, so that only leaves this spot to be a 13 or a 17. So again, that's everything it can be. So we've only got 4 spaces left, and we'll get some information about which cell's bigger or something like that. That'll get us the answer. So we're very close now. Just writing everything we've got. So we've got a 4, then a 5. That one's an 18. 9. C2 we haven't got. C4 is a 10. We haven't got that one, but we have got 11. Yeah, I thought this would be the case. A2 is bigger than D1. Is bigger than E2. That's going to tell us everything we need to know for the end. Just put in a 22 down there. So A2 is bigger than D1, which is bigger than E2. So this, start with the lowest, shall we? So E2, if that was 13 at the lowest, then that could only be a 17, and that could only be a 23. 17 to 23 are gone, so that's got to be a 13, and that leaves 7 as the only option there. So all of our numbers are in, we can put them all in the grid. And hopefully that's it. So hopefully that made sense, kind of walking through how to do that. I hope you enjoyed.